Hello there, it's Toby. Welcome back to the series where we make a programming language. We're making a programming language called SmallLang. It's a very small language to get your hands dirty and your feet wet making programming languages. Last time we added some runtime functions to have a baseline of functions that users of this programming language can actually use. So we were able to allow the user to write very simple programs such as this one, and this one can do some basic math and basic printing of strings. We should probably have added some string concatenation function, but there's always time for that. This time though, we're tackling something big. We're gonna implement Lambda functions, which are functions that look like this. In JavaScript, they call them arrow functions. And this is the primary mechanism, the only mechanism, with which the users of the language can define their own functions. You would define an arrow function and then just assign it to a variable, right? And that's a big deal, and that's where most of the power of this language is going to come from. In this episode, we're going to build the parser part of the Lambda function. So let's get started. We have an example of Lambda functions in their various forms. You can have a Lambda function here with no parameters. It has just a value on the right-hand side of the fat arrow. There's this implicit return, as is the case with JavaScript. If you need multiple lines within the right-hand side, you can use a curly bracket to surround the separate statements. Because this programming language is functional in nature, I decided to have implicit returns for the block style as well, which means whatever the last statement is within the block, the function will return the return value of that statement, which deviates from JavaScript, but I think it makes some of the things quite a bit easier in this language. It also means that an if statement is actually a function, and it's a function that takes a conditional and two functions, and it'll call this function if the conditional is true and call the other function if it's false. Also, an if statement, because it is a function, it will return a corresponding value, either to the return value of the first block or the return value of the second block. It always returns some value in this language, which also deviates from JavaScript. Okay, anyway, let's write the parser that can recognize this syntax. We're gonna say an expression, go ahead and add it in there, can also be a lambda. So what is a lambda? Well, a lambda is going to start off with a parameter list. It's going to start off actually with a left paren, some optional whitespace, and then a parameter list. I'm going to stick with my shorthand way of naming things. I called it arg list, and I'm going to call it param list in this case. It's important that we don't just simply use arg list, because whereas with an argument list, you can actually put arbitrary expressions like function calls in the argument list. In the parameter list, you can only put identifiers. So there's a param list and some optional white space, and then the fat arrow, and then some more optional white space. And then we have a choice here. We can either go for this one singular expression or go for this function block. I'm actually gonna extract a second symbol to handle that. So I'm gonna call that guy a lambda body. I'll handle it separately so I don't have to deal with so much stuff at once. Now I'm gonna have to define what a param list and a lambda body is, but let me finish this off and write a converter for this guy. So I'm gonna say I wanna represent the AST for a lambda to be something that has a type of lambda, and then it's gonna have a parameters array, which is going to come from our param list, and that's gonna come from index 0, 1, and 2. So data index 2, and then the lambda body, what index is that one? Let's count. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Body is gonna come from data index 8. So I think we have this rule now. Next, we need to define what a param list and a lambda body is as well. One thing about the param list is going to look very similar to the way the arg list is defined, so I'll do it in a similar style. There is a shorter way of doing it, which I am going to show that this time. I'll do it this left recursive way first. I'm actually gonna copy this and then just tweak it to save some time. So a param list is not gonna be an expression for each param, but instead be an identifier for each param. And then the left recursion says we should start with myself on the left, and then the right hand side should be this. So if we did this, then we have a working param list. However, I've done this pattern, this left recursive pattern 3 times. Once for statements, another time for arg list here, and yet another time for this new param list. And this is getting a little tedious. If you're wondering whether there's a little more convenient way to write this, and the answer is yes, you can. If we thought of this identifier as resolving to param list, we can think of it as, well, this part here, this mandatory whitespace followed by another identifier, that's the part that can keep repeating. And so we can use a repeat operator to do that. So we surround these 2 symbols with parentheses, and then we use a colon, which activates the repeat operators. And we're going to use the star repeat operator here, which means 0 or more occurrences of that guy. So if we did this, we actually don't need the first part anymore, but we'll need to change the converter here because the converter wants to return an array, but the first thing is no longer going to be an array. So data index 0 is going to be the first identifier, and then we have to actually ask what is going to represent this guy? Well, an array, because this is a repeating operator. So a repeating operator will always give you an array of stuff, and it'll give you an array of arrays. For example, if you had identifier A, B, C, A would go in here, and then this white space followed by the B is going to be wrapped in the first array. And then the white space followed by C is going to be wrapped in the second array. However, both of these arrays are going to be wrapped in an outer array because this guy has repeated 2 times. This guy repeated 2 times, 1 time, 2 times, and this repeater operator, its job is to repeat this guy. It repeated it 2 times, and it needs to return you the value. It's wrapping it in another array. So we end up getting this nested arrays like this, and we have to pick that back out, okay? If you choose to use this pattern, it's very important that you understand this nested array situation. So this whole thing is going to be at index 1 now, and index 1 is actually going to be an array. I'll call this repeated pieces. I don't know. And each repeated piece is going to be an array of 2 elements. I'll use map to go over this to grab second thing within the nested array. So I'll call this rest params. The rest of the params aside from this one. It's going to be the result of mapping through this guy and indexing into the index 1 to get the second one out of the array that has these 2 things. So if we do this and then spread it onto this outer array, then that should give us what we need. I will need to test this to verify that I did this correctly, but before we do that, let's make this lambda body. Okay, so what is a lambda body? Well, in the simplest case, without the braces, a lambda body is simply an expression. So we'll do that, and we'll use the ID converter. But in the more complex case, we actually have a left curly brace. I'll close the right curly brace as well. But in between the 2 curly braces, we're actually gonna have statements, a number of statements separated by new lines. We already have a thing that does that, so I'm just gonna try to reuse that guy. So I hope this works, although there's this sort of beginning white space here that we have not accounted for. We will need to account for that. But there's also this new line. I'm gonna say, okay, you can have some optional white space, a new line, and then the statement, and then another new line and some optional white space at the end. and that's your Lambda body. Actually, a Lambda body should be an array of statements. I think I should make it consistent between this one and this one. So for that reason, I'm going to wrap this one symbol inside of an array. Okay, so a Lambda body will give you an array, which goes into the body of the Lambda, and the body of the Lambda should be an array. So now let's write the converter for the block version of this. The thing I want is this statement, really. So that's going to be at index 0, 1, 2, 3. Okay, I'm going to try this. I think there will be problems, but we'll fix them if they come to be. Okay, there's actually a syntax error in my nearly grammar. So let's see, line 40. Did it mean a different place? Oh, it probably meant line 80. The error reporting of nearly.js needs some work. Perhaps I should fix that. I'm one of the developers of the project, so okay. I may want to look into that. Okay, so this guy should be an arrow function instead of a bar, because a bar can only come after the arrow function has already been started. Okay, let me try generating the parser again. Now let me try parsing this example. Oh, I think I have an error in my JavaScript. It's showing up on small.js line 61. It really corresponds to one of the lines of JavaScript that I wrote, but because this grammar file generates a JavaScript file, the error shows up in this JavaScript file. So I'm gonna try to figure out where that is. It's line 61. Oh, I forgot to have a return statement here. This needs to be in a return statement, and because this is the function body and then this is the actual object literal. So I have to regenerate the parser and try that one more time. Okay, we haven't allowed for empty parameter list, similarly to the argument list. And for the argument list, our solution was to use this optional specifier. And let's just do that again. So we'll use an optional specifier here to say that this param list followed by yet another optional whitespace. That's actually optional. And now that we have changed this index is going to shift because we removed one symbol from this list. This can end up being 7. And then the way of getting this parameters is going to be different now. 0, 1, 2 is still index 2 that we want to look at, but the content of index 2 might be non-existent because this is optional. Let's do a ternary to see if it exists. I'm going to go inside this nested array because it puts these two things inside of a nested array. So we're going to get the 0th one from that nested array. But if it does not exist, we're just going to use an empty array as the parameters. So let's try that. Regenerate the parser and run the parser. Okay, I think we got through this first line. Now it's complaining about this second line. Unexpected identifier token A. Instead, I was expecting to see one of the following. Either a whitespace, a closing paren, or an identifier token. So this doesn't really make sense because it says I'm not expecting an identifier, but yet later on it says I'm expecting an identifier token. So I think this could potentially be a bug in nearly.js. I guess one thing that I could try is going back to how I did it with the arc list and see if that solves the problem. Let me save this version though, so I can have it for later if I want it. But I'm going to change this guy to paramlist, change the express to identifiers, regenerate the parser, and run it again. This time it doesn't like the whitespace token on line 4. So I think it actually got through that problem. So there's something about this rule that doesn't work, which this rule solves. I would like to dig into that more. Like once I get to the bottom of why that is. Hey, it's Toby from a little bit later after having diagnosed the problem with this formulation of the paramlist. I had to do some heavy-duty debugging into the nearly.js library itself. Basically, what I found was that, so with this formulation of the paramlist, we had this error, which I said was extremely weird and seems wrong because it says I'm not expecting a identifier token, but then later on it said it is expecting the identifier token. It took me some digging to figure out that I simply misspelled identifier in this instance. There's a missing I here, so that's that one. So once I fix that, then this formulation of paramlist does work, and we're able to write it like this. It's unfortunate that the error message was not helpful enough for me to figure out the problem. It's also fortunate that it was not a bug in nearly.js, I suppose. Now, let's solve the next problem, which is this whitespace here. The grammar currently doesn't allow for whitespace in the beginning or the end of a statement. If we remove the whitespace, I think this will parse. Yes, it does. But I do want to allow for that whitespace. Indentation is pretty nice. This does work, but let's allow for that whitespace. And a way we could do that is allow for whitespace in here and here, like that, here. Okay, so, but now if I do this, the index is going to be off. And if you retest your, if you forget about this, you're going to get an error later. So I'm going to add 1 to the index to grab that guy, and here the index is going to be off for this guy. So this index for this is 0, 1, 2, 3 now. So let me try this. Regenerate the parser, and then parse it, and it actually works now. It's able to parse this file with the Lambda expressions in it. Let me look at the AST to verify that it is correct. So, okay. So the first statement is a var assign. We're assigning to f with the value of a Lambda function. The Lambda function has no parameters, and it has a body, which just has the one expression in it, and which is just a number. So that makes sense. The second one is another variable assignment. We're assigning to g with the value of a Lambda function with parameters a and b, and then a body which has a function call to the function add, and which has nested function calls, and so on and so forth. Let's look at the next one, h. It's a variable assignment to the identifier h. The value is a Lambda function with x and y as the parameters, and then its body has, the body is an array, 3 separate statements in the array. The first one is a function called to print. That looks right. I think so is the second one. And then the third one is actually a function called to g. So all of that checks out. And so I'm confident that this is working at the moment. So I'm going to end this episode here. See you next time.